be looking at physics, part 2. Part 1, we explained the meaning of physics. We say it's science that deals with the study of matter and energy. We also say it's the science of measurement. And we looked at, we also say it's the science that deals with the measurement of physical quantity. We look at the physical quantity. We classify them into 2. We say we have the basic physical quantity and we have derived physical quantity. So the basic physical quantity, we mentioned 7, although 5 of them are for your IGCSE programs. And we give the quantities, the unit and their unit symbols. We say length, the first one is length, and we say the unit is meter, and the symbol for the unit is m. And then the second one is mass. The unit is kilogram, and the symbol is kg. We say the third one is time, and the unit is seconds, and the unit symbol is s. The fourth one is electric current. The unit is ampere, and the symbol is capital letter A. The fourth one is temperature, or you can say thermodynamic temperature, and the unit is Kelvin, and the symbol is K. And then these are the 5 for your IGCSE, but we added 2, which includes your A level. And we say for A level, you add amount of a substance, the unit is mole, and the unit symbol is MOL. And the 7th one is the light intensity or luminous intensity, and the unit is candela, and the unit symbol is CD. Now, here is a temperature that is given that says the conversion of temperature in Kelvin to degrees Celsius. So if you have temperature, temperature is measured in degrees Celsius, but in this case we are measuring temperature in Kelvin. Is one of the temperature scale. Okay? So temperature in Celsius, if you want to convert to temperature in Kelvin, is the amount you measured in degrees Celsius. We can call it X. So let's say if someone is 36 degrees Celsius, you put 36 here in this place of X, plus 273. If you want to convert the value to Kelvin, you add 273 to it. Okay, so this is the formula for converting Kelvin temperatures to Celsius temperature. Okay, so this is the formula for converting temperature in degree Celsius to temperature in degree Kelvin. In this place of X, you can put T Celsius. Here, someone else might write, instead of say X, you might write temperature in Celsius. You say T degree Celsius. You can put this one degree Celsius. Okay, temperature in Celsius plus 273 equals to temperature in degree. Equals to temperature in Kelvin, plus 273 equals to temperature in Kelvin. So then the question is, some textbook may use X, some textbook may put T in degrees Celsius to tell you it's temperature in degrees Celsius. Now the question is, what if they've given me the temperature in Kelvin, I want to convert to Celsius. So you just make this one the subject. So you make this one the subject, become TC, temperature in degrees Celsius will be equal to, okay, this one you do in thermophysics also. Okay, we're just showing you the conversion. This one equal to, bring this 273 to join to meet degree Kelvin. So it's degree Kelvin minus 273, because when 273 goes to meet degree Kelvin, it will become minus. It's like you move this one to the left, it becomes minus 273. So if I have degree Kelvin, I want to change to degree Celsius, I will say whatever they gave me degree Kelvin, like 298. If they give me a temperature 298 Kelvin, they say change it to degree Celsius. They gave me 298 Kelvin, they say change it to Celsius. I'll put the 298 here minus 273, I'll get my either 50 degree Celsius. Okay, that's that for temperature in. So these are the basic physical quantity that we talked about. We say the derived physical quantities includes like speed. Speed is derived quantity. Speed is distance over time. Okay, these are the basic one, the one that are natural, that are not derived. They're not obtained from any other physical quantity. And then the derived quantity includes the speed, acceleration, force, all of them, they are all derived. Okay. Now let's take a look at, when you do measurement, the kind of errors you find in measurement. types of error. When we carry out measurement, we always find error. And in paper 6 of physics, they always ask us which type of error is you can find, or how to avoid error. Okay, how to avoid error, or how to get more accurate results. So we always mention this. These are the errors that may occur in an experiment when you carry out an experiment. And this will make your result to differentiate, to make them differ from each other. One of the errors is the parallax error. What do we mean by parallax error? Error due to parallax, the way you look at the results, or the angle at which you are looking at the result. So if you are making measurement from here, your eye level must be directly here. Your eye level must be directly here. That's when you can get the accurate. You can avoid error due to parallax. That's when you can avoid error due to parallax, if you are making measurements somewhere here. Okay, but if you're standing here, your eye level is from this angle, you're looking at it, you're definitely going to read wrong, have errors in your readings. You're definitely going to have errors in your reading if you're not standing there at line of sight. If you're not on the line of sight to the spot that you carry out measurement, you have what we call error due to parallax. Now the problem of the eye position when you're reading this measurement is error due to parallax. When your eye position is when you're reading a measurement is error due to parallax. So if you're directly on the eye level, if you're directly viewing the contact on a strong line of sight, a straight line of sight, you will have more accurate results. So you'll be able to avoid error due to parallax. But if you are standing at an angle to a position, you are not on the straight line of sight, then you might result to what we call error due to parallax. This error results from your eye position level to the spot that you're carrying out your measurement. Then the second type of error you have in experiment are called the zero errors. Okay, the problem of the measuring tools, they result to what we call the zero errors. These are not your problem, these are the measurement instrument, the instrument you're using in measurement. Okay, the equipment that you're using to carry out your measurement, if they cause the error, you call them the zero errors. Okay, you call them the zero error. Now, before we continue to density and volume, let's quickly go back to the real basics of what we have. Let's take a look at this tutorial on the measuring, because we want to start to look at the measurement of each of these. We mentioned 5 basic physical quantities. So we have to look at how to measure length, how to measure mass, how to measure time, how to measure electric current. Before we start, most especially these first 3, we have to look at this measurement of these first 3. After that, it's very important to know how to carry out measurement of length, measurement of mass, and measurement of time. It's very, very important. After that, then we look at, density is mass over volume. Length times length times length gives volume. Length times width or times height, or you say length times length. So it gives volume. So we study volume a little bit, and then we study density from these 3, and so on and so forth. Then we move to the next one. So let's quickly expound on the knowledge that we have here, the scope we have here, and be able to move forward. So let's take a look at the measurement of length and volume. Let's listen to this tutorial on measurement of length and volume.
On how to accurately measure the length and volume of both regular and irregularly shaped objects. How can we measure with a scale? Volume can be found only by viewing the scale with your eyes directly in line with it. This reduces the parallax error and should be stated in your method. The exact length of this pencil can be found only by viewing the scale from directly in front of it. This example shows a micrometer scale read from different angles. The viewer must be directly above the reference line to be able to read the correct measurement. Parallax error can be obtained when reading any type of scale, even small ones. We can measure the volume of fluid in a cylinder by bending down to view the meniscus straight on. This also reduces the parallax error. increasing the accuracy of the experiment. You can see here that different volumes of fluid are obtained when reading a measuring cylinder at different angles. Good scientific practice dictates that we can increase the accuracy of an experiment by taking multiple readings of all experimental measurements and finding the average of these to give the final value. For each object, the results table shows space for 3 measurements of diameter in the diameter column and space for the average shown by the average column. All experiments need a clear set of results. What equipment could be used to measure length? Vernier calipers are used to measure the diameter and thickness of small objects. You do not need to understand how they work. A ruler can be used to measure small distances of a few centimeters. In the diagram, the extension of a loaded spring is measured to the nearest millimeter on the ruler. A ruler is a common but essential piece of equipment. Don't forget to mention it in any experimental method. A tape measure is ideal for finding lengths up to a few meters. A trundle wheel can be used to determine distances up to a few hundred meters. Once you have the correct measurements for the dimensions of an object, you can convert into the standard units of meters. Remember the basic mathematical formulae for volumes of regular shapes from your maths course. For example, the volume of a cylinder is equal to pi times the radius squared times the length. In this example, we will calculate the volume of the ball bearing. Measure the diameter using the vernier calipers. Here this is 22 millimeters. Convert the diameter into meters. This gives 22 times 10 to the power of minus 3 meters. Substitute the value into the equation for the volume of a sphere. V is equal to 4/3 pi times radius cubed, which is half of the diameter. 4/3 times pi times 11 times 10 to the power of minus 3 cubed equals a volume of 5.58 times 10 to the power of minus 6 meters cubed. Show each step of the substitution. You can still earn some marks even if you make a mistake. A measuring cylinder tells us the volume of the liquid inside it. An irregular solid is placed inside the eureka can. Its volume is equivalent to the volume of the water displaced. The height of the liquid in the cylinder increases by the same amount as the volume of the object added. In this example, we can find the volume of an irregular shape. Measure the volume of fluid in the cylinder, which is 24 centimeters cubed. Add the rock sample to the cylinder. Measure the new volume of fluid, which is 31 centimeter cubed. Calculate the new volume of the rock sample. This is 31 minus 24 to give 7 centimeters cubed. Remember that 1 millimeter of displaced water is equal to 1 centimeter cubed of water volume. Bend down to be eye level with the bottom of the meniscus in the fluid to measure the volume. In summary, good experimental procedure in physics includes reading the scale directly in line and taking multiple readings to find an average. You should be familiar with the specific equipment used to measure objects of different sizes. You can use mathematical formulae to calculate the volume of different regularly shaped objects such as spheres, cylinders, or cubes. You can add any object to water and calculate the increase in volume if it is hard to measure its dimensions. Don't forget to check out all our other fantastic revision resources here at Save My Exams.
Okay, quickly we've gone through this tutorial, and let's quickly measuring of length. There are different instruments for measuring length. One is the measuring tape, which is used for measuring long lengths. Okay, the second one is the meter rule, the one you call ruler, meter rule, which is used for measuring few centimeters. The third one is the vernier caliper. Okay, and the fourth one is the micrometer screw gauge. So these 4 instruments, they technically used for measuring length. In measurement, what we normally do, if you want in the exam, they will ask you how do you improve accuracies? How do you improve accuracies of your measurement? You can say by measuring, repeating the experiment more than once and finding the average value. Meaning, if you measure a length, do it more than once. Do it more than once, measure it first time, do it again second time, do it a third time. You add the values together, divide by 3. That's average. You find the average value. So average value is one way to improve the accuracy of your measurement from your experiment. So first of all, I said there are about 4 instruments for measuring length. Measuring tape for measuring few meters, meter rule for measuring few centimeters, and then you have up to 1 meter. Then we have vernier caliper for measuring the diameter of a very small circular object, small objects. Then a micrometer screw gauge for measuring very small diameter of a tiny object like a wire. Okay, the thickness of a wire, the diameter of a wire. So these 4 instruments, we're going to find a place to look at the vernier caliper and micrometer screw gauge, even if they don't talk about it. We need to know how to use it. It has 2 scales. The vernier caliper has 2 scales, the main scale reading and the vernier scale reading. So how to take the measurement from each of them. But before we get there, if you want to measure the volume of a stone, you know a stone is an irregular shaped object. First of all, you pour some liquid or like water into a measuring cylinder, let's say 24 centimeter cube. Okay, then you write down the volume of the water originally before you put the stone inside 24 centimeter cube, and then you put the stone, irregular stone, inside the same water, inside the same 24 centimeter cube of water. You see the volume would have increased to about 31 centimeter cube because you put a stone. So to find the volume of stone, because stone is irregular shape, you cannot measure the volume of a stone. It's not a regular shape that you can calculate the volume. So this is one way of calculating, easy way of calculating the volume of an irregular shaped stone. Okay, so you now do the volume with the stone minus the volume without the stone. So 31 centimeter cube minus 24 centimeter cube, which gives you 7 centimeter cube. What it implies is that this stone, the volume of the stone is 7 centimeter cube. So this is how to measure volume of irregular shaped object. But for regular shape is easy. They all have mathematical formula. Volume of a circle, you can as a volume of a cylinder. Volume of a cylinder you can easily calculate. If it's a cylinder, you can easily calculate the volume, right? We can easily calculate the volume. We can say V equals to pi r square H or pi r square L, depending what you call the cylinder. So you can easily calculate the volume, right? If it's a cylinder. So if we're talking about cylinder, you want to calculate the volume. Because it's regular shape, V is what? Pi r square. V is equals to pi r square H for a cylinder, okay? So for any regular shape, there's a formula to calculate the volume. So it's not a big deal. So if I give you a cylindrical shape, here is a cylindrical shape. If we give you a cylindrical shape and we say calculate the volume of this object, calculate the volume of, maybe there's a liquid inside this place, say calculate the volume of whatever it is, and then you already know the height. Here is the radius. Okay, here's the radius R. Here's the radius R. Okay, see this is too thick. Let's reduce a little bit. Here's radius R. Okay, here is the height from here to here. You have the height H, or you can call it L. It doesn't matter whether you call it L or you call it H. Okay, so this is how the formula comes. Pi r square for the circular part is the area of the circle. You know the area of the circle multiplied by volume is always area times height, right? Area. This pi r square is the area. Is area. Area times height is the volume. So you can see this formula is same as saying area times height. So this pi r square is the volume of the area of the circular part. Pi r square, then multiplied by the height or multiplied by the length. We get the volume of the cylinder. So if the object is a cylinder, if it's a cube or a cuboid, we can just say volume is length times height, length times width times height. So length times width times height. You can calculate the volume. So we can easily get the volume of any regular shape, but if it's irregular shape, you put it in a water. You measure the volume of water first, then you put it inside the water in a measuring cylinder. You minus the two volumes, and you'll be able to get the volume of the regular shape, of the irregular shape. Is it okay? Is that okay? So that's that for that. Here we can find from here, you can see from 4 to 12. They can ask you what is the diameter of this 4 small circular ball. Okay, you can find the diameter. So from here to here, 2, 2, 2, 2. That's about 8. 4 to 12 is 8. So the diameter of this 4 ball does say 12. So student will just rush and say the answer is 12. The answer is not 12. 12 minus 4, it gives you 8. So the diameter or the total length of these balls, these 4 balls together, is from the ruler measurement. The total length is 8. Okay. If you want the diameter, if you want to calculate the diameter, say diameter is the total length divided by the number of balls. Okay. Total length, the total length of this one divided by the number of balls. The total length is from here to here is 8 centimeters. Divided by number of balls, there are 4 balls, so you get 2 centimeters as the diameter for one. The diameter of one of the ball. If you want the diameter of one of the balls, is that okay? Okay, but the diameter of the 8 balls is 8. The diameter of one of the 4 balls, sorry, the diameter of the 4 balls is 8. The diameter of one of the ball is 8 divided by 4 number of balls, which gives you 2 centimeters as the diameter of one of the balls. Okay, of the ball. Now, for time, there are different instruments for measuring time, right? There are different instruments for measuring time. Now, let's go to measurement of time. We talked about length and volume. We've talked about length and volume. Let's talk about time a little bit, okay? Because we are trying to summarize this chapter. Now, for time, there are different instruments we use for measuring time. We have the stopwatch, we have the clock, digital clock, analog clock, and so on and so forth. But the most important, the clock is easy, or the stopwatch is easy. A stopwatch is used to measure time, okay, for maybe for athletes, those who are running, like 100 track, 200 track, 800 track, and so on and so forth. So the time it takes them, we start the clock, and the clock starts to, the moment we say go, we blow the whistle for go, we start the time and we start to record till the finish time, and then we take measurement of the time. So a stopwatch is used for measuring time, and we record the time in seconds. Is that okay? We record the time in seconds. However, there's another instrument that we use for measuring time. It's called the pendulum, simple pendulum. This is the one you normally find in the exam, paper 6, the simple pendulum. Okay, here we tie the ball, bob, very hard metal. We tie it to a thread and hang it on a resistor stand, and we swing it. We allow it to oscillate. We fling it to one side. It starts to fling left, right. Okay. If you fling it here, if you go and come back, that's one oscillation. 1 goes again, come back. 2 goes again, come back. 3 goes, come back. 4, 5, 6, 7, 8, 9, 10. That's 10 oscillations. So if they give you 10 oscillation, you start your stopwatch as it's oscillating. Okay, the first time you do it, you record the time, you call it T1. So you record the time, you call it T1 for the pendulum. So you write the time, T1. You record the time, maybe let's say 5 seconds. Time in seconds, so I say /S. Time in seconds, you write 5. Then you do another one, because in experiment we don't do once. Because you'll not be able to get accurate result if you do only once. You do the second one, T2, maybe you may get 5.2. You may get 5.2 this time around. Or here you get 5.4. And now you're getting 5.2. You can see? So here you will now find the average, T average. Okay, T average. This average, I will use this kind of symbol like this, T average. Okay, average time. So what it means, you add T1 plus T2 divided by 2. If you do only 2 times, you divide by 2. If you do 3 times, you divide by 3. Okay, so you will say 5.4 plus 5.5, you get 10.6, right? Divide by 2, you get 5.3, right? 5.3. So you get 5.3 if you divide by 2, right? So 5.3 is the most accurate value of that time measurement. Is the most accurate value of that time measurement. So it means it will take 5.3 seconds more accurately for the 10 complete oscillation. So this is the average value. Now, if you want to find the time period, because in the experiment, time period is capital letter T. The time period is also in seconds. If you want to find the time period, please pay attention, because this is your paper 6. If you know what I'm showing you now, then you're done. Even if it's only one example I'm showing, you're done. To find the time period, you say the average time divided by number of oscillation. If you do 20 oscillation, you divide by 20. If you do 10 oscillation, you divide by 10. Please, it's not compulsory you must divide by 10. Don't say, oh, the formula I learned from waidusmacademy is average time divided by 10. If there are 10 oscillations, you divide by 10. If there are 20 oscillations, you divide by 20. So it depends on what the question tells you. If the question says there were 20 complete oscillations, you go to say the average time, what you got here, 5.3, divide by 20 if there are 20 complete oscillations. Okay? You are going to divide by this average time, divide by 3, divide by 20 if there are 20 oscillations. If there are 10 oscillations, you divide it by 10. Divide it by 5.3 divided by 10 there. So you get 0.53 if you are divided by 10. If you are divided by 20, you get 0.25 something. Okay, so that's what it is in the measurement of time. And then we plot graph of length. Here, we're going to choose the length of the thread. You know the thread you are using? You're going to choose the length. Or the length, how long the thread will be for you to insert the bulb. Maybe 90 centimeter, 80 centimeters, 60 centimeters. So you change, when you do for 80 centimeter, length is in centimeter in this regard, and then you carry out another measurement. When you do for 70 centimeter, you do another measurement. When you do for 70, same again, you carry out all the values. So you get tables of values. Okay, you get tables of values, and then you can plot your graph based on what they ask you to plot in the graph. You can plot your graph based on what they ask you to plot. The next length may be 70 centimeter, and then you write the whatever value you get for your T1. If you reduce the length of the thread, this is what I mean by the length of the thread. This one. You keep changing this length. Maybe first time 90 centimeter, then you oscillate. And then second time 80 centimeter, you oscillate 2 times. You record T1, T2. Third time, you change to 70 centimeter, you oscillate. You get the first oscillation, T1. For 10 oscillation or 20 oscillation, you record time T1. You do it again. 10 or 20 oscillation, you record time T2. You find the average value, you find the time period. You change the letter again to 60 centimeter, 50 centimeter, depending on how the experiment wants you to, as much as the experiment wants you to go. At the end of it, then you plot the graph. Okay? At the end of it, you plot the graph. You plot the graph of length against the time period. So you plot the graph of length against time period like this. A graph of length against time period. This is the time period T, capital T. This is your time period, and this is your length. Okay, you will get an exponential graph like this that looks like this. You get an exponential graph that obviously or probably looks like this. You get an exponential graph that will probably look like this. It shows that as the length increases, the time period also increases, but exponentially. So these are the things you will find in this aspect of physics in paper 6. Okay, these are the things you find in paper 6. Okay, so I've just explained that. So that's the end of this first section from this one. And let's see if we have anything else to add to what we said. Maybe now we'll go to mass. And there's a tutorial for mass. We'll look at that tutorial. Okay, so let's okay, so let's go to measurement of mass. Now let's talk about mass a little bit before I move to density. Now because I've talked about measurement of length. I measure the instrument we use for measuring length. But however, we will find a class for vernier caliper, how to use vernier caliper and micrometer screw gauge. Okay? If not this class, we'll find a class for it. how to use it to measure, the drawing and everything, the measurement and everything. Okay, now let's take a look at, we've also looked at measurement of time. So we've talked about measurement of length, measurement of time. Now let's take a look at measurement of mass. Mass is the quantity of matter content in a body. Mass is the quantity of matter in an object. The quantity of matter, how much matter an object has, is the mass. Okay, when you talk about mass, you're talking about the matter content in an object. And it is measured with kilogram. It is measured with what? Kilogram, kg. The unit is kilogram. Okay, the instrument we use is, you can say, scale or beam balance. The unit is kilogram, and the instrument we use is a beam balance. We use a beam balance to measure mass. We use what? Beam balance to measure mass. Beam balance to measure mass. That's the instrument we use for measuring mass. Okay, mass is a scalar quantity. Mass is a scalar quantity. It's not a vector quantity, meaning it only has magnitude, does not have a direction. Okay, so you need mass, you need to know about mass of object in order to, if you want to measure an object, you put it on a scale. Okay, you put it on a scale. You put the object on a scale. Okay, you put it on a scale and you measure the mass. The scale will tell you, is calibrated, will tell you in kilogram or in gram the mass of the object. The scale will tell you how much mass of the object has. Just put the object here, it will weigh. It will weigh and tell us the mass of the object. Okay, once you know the mass of the object, remember we already studied volume. We say volume of objects are the mass, volume are the length times the width, if it's a regular shaped object, times width times height. And we also say volume for cylinder is pi r square h. Pi r square h. For cylindrical object, the volume is calculated as also area. Remember, length times width is area also. This is same as area times height. Okay, volume is still, even in this place, is same as area times height. Here, volume of cylinder is same as area times height, because the pi r square is area. The pi r square is area. It's also area times height. So different object. If you have a spherical object, a 3D sphere, the volume is 4 over 3 pi r square pi r cube. 4 over 3 pi r cube h. Okay, 4 over 3 pi r cube h. Okay, see, this is also a pi r square h for volume. Okay, pi r square, 4 over 3 pi r square h. So this is the volume of a cylindrical, of a sphere. If you have a spherical object, this is the volume. So once we know how to calculate volume and we know mass, then we can calculate the density. Now let's go to density. Density is simply, okay, we come back here, we have micrometer, screw gauge. Okay, before we go to, so that we not jump, let's quickly take a look at let's quickly take a look at density, then we'll come to micrometer, screw gauge. Density and volume. We already talked about volume. Density is simply mass over volume. The density of object, density, so I will use D, okay? Although it has a symbol. It has a symbol like this, like rho. The density of object, so either I write this symbol. This symbol is not E. It looks like E, but it's elongated E. The density of object is the mass of the object divided by the volume of the object. The mass divided by volume. So we have a triangular formula for density. Density, as it were, is mass of the object divided by the volume of the object. The mass of the object divided by the volume of the object. Density of an object is the mass of an object divided by the volume of the object. Okay? So we've talked a lot extensively on the mass. We say the instrument for measuring mass is beam balance. We say the unit of mass is kilogram. Okay? The unit of mass is what? Kilogram, kg. That's the unit. The unit symbol is kg. The volume is, we've talked about volume of regular shape object, volume of irregular shape object, how we can obtain these volumes. So density is mass divided by volume. But what if you want mass? Mass is volume times density. If you want mass, it's volume times density. If you want volume, it's mass divided by density. So these three can be interchangeably used. Okay? Can be interchangeable, which means density is directly proportional to mass and inversely proportional to volume. Is that okay? We've talked about measuring volumes. We've used the mass formula for calculating volume of regularly shaped object, and irregular we've said is displacement method, displacement of water displacement method for calculating the density of irregular shaped object. What it is, you put some water in a measuring cylinder, then you put the irregular shape like a stone in the water, the volume will increase. Measure the first volume, measure the second volume, then you subtract. You get the volume of irregular shaped object. Is that okay? And then we say density is inversely proportional to volume, but directly proportional to mass. Is that okay? So that's for density. Okay, you need to know the density of different substance. Solid, liquid, and gas, and they all have the different density. Mass, solid have more density than liquid, and liquid has more than gas. Okay, so detail of this will be explained in the notes thereafter. Now let's take a look at micrometer, screw gauge. You know, when we talked about measurement of length, we talked about four instruments for measuring length. We say the measuring tape, meter rule, vernier caliper, and micrometer, screw gauge. This is the diagram of a vernier caliper. It has two scales, the main scale and the vernier scale and the thimble scale. This main scale is called the sleeve scale, and while this round one, the circular one, is called the thimble scale. Either you call it the circular scale or you call it a thimble scale. What the main scale really is the value before the thimble scale. Any value that you have here. This is, if this is 0, this is 1. Okay, this is 1. Here will be 0.5 below here because it's between 0 and 1. Here is 0.5. This place 0.5. 0.5. Here is 2. This one is 1.5 because it's between 1 and 2. This one is 3. The one top is 3. This is 4. This is 4. This is 4. And here is 2.5. Here is 3.5. So the last one here is 4. So here we have 4 millimeter because it's usually calibrated in millimeter. So here the sleeve scale reading, how to read? Read is to add, to read the vernier caliper is to add the two scales. It has two scales. We have to add the main scale. Read is equal to M. When I say MS means main scale or sleeve scale. Main scale. Main scale plus thimble scale. Okay, or you say sleeve scale, you can say SS. Sleeve scale plus thimble scale or circular scale. Circular scale. Or you call it thimble scale. Thimble scale. So you add. So what do we get here in the main scale? 4 millimeter. And how to use? You put the object 4 millimeter. You put the object you want to measure here. Put the small is used for measuring the diameter of very tiny objects. You put the object here. Then you knob here. This ratchet knob is to close it. Is to fix these two spindle and the RV to hold the object tight. To hold. You begin to screw here. When you screw it here, it will hold this object tight. Because this one will continue to extend outward. To the spindle will hold the object tight to the RV. This is RV. RV, A-N-V-I-L, RV. It will hold the object to the RV very tightly. It will hold the object to the RV very tightly. And then once that is done, then you start your reading. So you read it. If the last one was the one at the bottom, it will be 4.5. For example, because the last one before we reach this circular area is the one on top. If the last one is the bottom one, if there was something here before there was a small one here before the main line, it would have been 4.5 millimeter. The reading would have been 4.5. But the last one was 4. So that's why we read this one as 4 millimeter. Then plus, you now read the circular one. How do we read the circular one? To read the circular one is to read the value that tallies with this horizontal line is 5. The value, if here is 6, you measure 6. If here is 7, you measure 7. Okay, whatever value tally, this one tally with the horizontal scale, is the value of the timbo. So you take that value, that 5. Here, in this case, it's 5. You take that timbo value, you multiply by 0.01. Okay, you don't just write 5 millimeter. You multiply with 0.01. You multiply with what? 0.01. That will give you 0.05. It should give you 0.05. 0.05 millimeter. So you add that 0.05 here. You add the 0.05 here. So you get 4.05, right? You get 4.05 millimeter. So your reading will be 4.05 millimeter. So this is how to read a micrometer screw gauge. Similarity is done with vernier caliper. Vernier caliper also have 2 scales, main scale reading and vernier scale reading. The main scale reading is after you put the object that you are measuring, the main scale reading is the reading before the zero mark on the vernier. Before you get to the zero mark on the vernier, the main value you have on the main scale, you write it down. The vernier scale is where you have intersection. If you, we are explaining the vernier caliper now. Where you have a straight line intersection, straight line for both the vernier and the main scale. There you have it, straight line. You read that value, multiply by 0.1. That one you don't multiply with 0.01, you multiply with 0.1, and you add them together, you get your vernier caliper reading. Okay, so that's that for the first segment of this class. The next one we're going to go to force and motions. We study speed, acceleration, distance, displacement, and so on and so forth. So with this, we come to the end of chapter 1. So we'll be taking chapter 2 in our next class. Thank you.